Hello students, today under the topic of the nitrogen compounds, we will study about the nitric acid. Nitric acid is a student, a important compound of the nitrogen family. The chemical formula of nitric acid is HNO3, and in nature, this nitric acid is formed by the reaction of nitrogen and oxygen under the thundering activities that takes place during the rainy season. It also presents in the form of the nitrates of the sodium and potassium in the soil, which is very important manure or fertilizer for the plants. So students, let's see how this nitric acid is prepared in laboratory and how it is manufactured at the industrial scale. So first of all, let's understand the formation of the or preparation of the nitric acid in laboratory. Laboratory preparation of HNO3. In laboratory students, it is prepared by the reaction of the sodium nitrate with sulfuric acid, that is H2SO4. Let's see how this reaction takes place. NaNO3, in the name of this compound is sodium nitrate. When sodium nitrate reacts with sulfuric acid, that is H2SO4, and they are heated together, then sodium hydrogen sulfate, that is NaHSO4 plus nitric acid HNO3 is prepared. Name of this compound is sodium hydrogen sulfate. So students, in this reaction, nitric acid is prepared in the and it is obtained as a product. Let's see the setup or the diagram for this reaction, that how this reaction takes place, which type of the vessels are required for this. See students, this is the arrangement of the apparatus to prepare the nitric acid in laboratory. Here we see that in a closed vessel, a special necked type vessel, in which the sodium nitrate and sulfuric acid are mixed together and they are slowly heated. During the heating of these compounds together, they react with each other. Here, this combined with each other by the heating, and they prepare sodium hydrogen sulfate, H2SO4, and nitric acid. Here, the nitric acid is obtained, and here a continuous shower of the water is poured on the vessel in which nitric acid is collected, because it generates a lot of heat. So in order to minimize the temperature of the vessel, a continuous shower of the cold water is poured on it. In this way, we obtain the nitric acid in laboratory. Now, secondly, see how this nitric acid is manufactured at industrial scale. Students, in order to prepare or manufacture the nitric acid at the industrial scale, three different types of the methods are applied on it. The name of the three method is, the first one is a retort process. We call it retort process. This process is nowadays not too much in use, but during the beginning of the knowing nitric acid, this method was the major method by which the nitric acid was prepared. The first one is a retort process. Second one is arc process, or it is also known as electrical arc process. And third one is Ostwald process. Now students, let's see in detail all these three methods one by one, that what are the step by step procedure to follow these processes. A retort process is nowadays not very much useful, but during the ancient time or in the beginning it was very useful. Let's see which type of the reaction takes place in a retort process. In retort process, potassium nitrate, that is KNO3, react with sulfuric acid H2SO4 to produce nitric acid and potassium hydrogen sulfate. Let's see the reaction. KNO3, that is potassium nitrate, reacts with sulfuric acid H2SO4 to produce potassium hydrogen sulfate, that is KHSO4, and nitric acid. This is a reaction that takes place in the retort process. Now see the second method, that is arc process, which is very important method of the preparation of nitric acid, because it uses the air to prepare the nitric acid. Let's see the main type of the reaction which takes place in this process, and then we will see the setup of the apparatus which are required in this method. First of all, if we see the reaction, then the beginning of this process takes place with the reaction of nitrogen and oxygen that are present in air. So, the very first reaction of this process is N2 plus O2 gives to 2NO, nitrogen oxide, along with the elimination of 43 kilocalorie of the energy. A huge amount of the heat is released, so minus 43 kilocalorie energy is released in this process. Now this NO again react with oxygen in the second reaction. This 2NO again reacts with O2 to form 2NO2, that is nitrogen dioxide. Now students, this nitrogen dioxide reacts with water to produce nitric acid. Third reaction, this 2 nitrogen dioxide reacts with water, that is H2O, to produce HNO3, nitric acid, plus HNO2, that is nitrous acid. Now this is nitric acid that we required, and this nitrous acid again the recombination reaction takes place, and in recombination reaction water, nitrogen oxide and nitric acid is produced. Let's see how. The fourth reaction that takes place in this process is 3HNO2 gives to rearrangement reaction HNO3 plus H2O plus 2NO. Now students, you can see that in two steps nitric acid is obtained, and again the third product is nitrogen oxide is obtained. This nitrogen oxide or NO again can be used here to prepare the nitric acid. So the most important benefit of this reaction is that it starts with the air. The nitrogen and oxygen that are present in air are the raw material for the preparation of nitric acid in this arc method. Now students, we will see the setup of the apparatus which is required in this process. See students, here this is the setup for the arc method for the preparation of nitric acid. In this setup students, an electric furnace, you can see here this electric furnace contains two electrodes at which a high potential electric charge is flowed. Here the air is intaken from this chamber, and due course of the electric arc that takes place in the middle of the electric furnace, the combination of nitrogen and oxygen takes place and formation of nitrogen oxide also takes place. So this reaction, the very first reaction takes place in electric furnace, then it moves forward and cool down. Due course of the electric charge, the temperature of the nitrogen oxide is very high. So here in cooling chamber it is cool down, then again it move forward, and in boiler it starts boiling. Next, the oxidation process takes place in next chamber, where the nitrogen oxide combines with oxygen to form nitrogen dioxide, that is NO2, and this second reaction, that is oxidation reaction, takes place in oxidation chamber. Now it moves forward, and in the last step, the third reaction, that is the reaction of nitrogen oxide with the water, takes place. You can see here, this is water shower which reacts with the nitrogen dioxide that is coming through this pipe, and they react together to form the nitric acid. This nitric acid students can be obtained through this step in the bottom of the container. In the fourth reaction, nitrogen oxide is left out, which can be collected through this pipe, and this nitrogen oxide again can be used to form the nitric acid. So students, this is all about the arc method. Next is Ostwald process of the formation of the nitric acid. So let's see which are the main steps of the Ostwald process and which reactions are takes place in Ostwald's process of the formation of the nitric acid. Ostwald process of formation of the nitric acid students starts with ammonia, oxidation of the ammonia, in which ammonia combined with oxygen to form nitrogen oxide, and the second and third step will be nearly similar to our previous reactions that we have seen in arc process. Let's see. The very first reaction of the Ostwald process is start with ammonia NH3, 4 molecule of NH3 combines with 5 molecules of oxygen to form 4 molecule of nitrogen oxide along with the formation of 6 molecule of H2O. Now you can see here that we obtained nitrogen oxide NO that we used in arc method for preparation of nitric acid. So here the second steps in which 2 molecules of nitrogen oxide combines with oxygen again, that means its oxidation takes place and formation of nitrogen dioxide takes place, that is 2 molecule of NO2 are formed. Now this nitrogen dioxide combines with water and form nitric acid along with the formation of nitrogen oxide. So in the third step, 3 molecule of nitrogen dioxide combines with 1 molecule of water to form nitrogen oxide along with the formation of nitric acid, and 2 molecules of nitric acid are formed in this reaction. So students, in Ostwald process, this Ostwald process takes place in 3 steps. 3 different reactions takes place in Ostwald process. First reaction start with the oxidation of the ammonia, in which 1 molecule of ammonia combines with 4 molecules of ammonia combines with 5 molecules of the oxygen to form 4 molecule of nitrogen oxide here and 6 molecule of water. These nitrogen oxide molecules again combine with oxygen to form nitrogen dioxide. This nitrogen dioxide combines with water to form nitrogen oxide and 2 molecules of nitric acid. This nitrogen oxide again can be used in the place of this nitrogen oxide, and again it can be used to prepare nitric acid. So students, these are the 3 different methods to prepare the nitric acid. Now let's see what are the main properties of the nitric acid. Whenever we talk about the properties of any chemical compound, then we take 2 types of the property, physical and chemical. So first of all, let's see the physical properties of the nitric acid, and then we will discuss about the chemical properties of the nitric acid. First of all, in physical property we always consider the color of the substances. So it is colorless. The nitric acid is colorless. Second, its boiling point. Nitric acid, boiling point of nitric acid is 83 degrees Celsius. It boils at 83 degrees Celsius and its freezing point is minus 41 degrees Celsius. It solidifies at minus 41 degrees Celsius. Next important property is its taste. Obviously, if it is acid, then it will taste sour. So its taste will be sour in taste. If you consider the smell, then it has very sharp pungent smell. So fourth property is pungent smell. As it is an acid, it can produce blisters whenever it touches our skin, because the acids have the property to produce the blister on the skin. The nitric acid which is obtained by any of the 3 methods, in beginning it contains only 68% of the nitric acid. Its concentration is 68%, but by different methods, by the oxidation methods, it can be converted into concentrated acid, nitric acid, which is very powerful, which can produce much effect on our skin as well as the substances on which we apply it.